I'm nervous since that clock stopped.
Welcome to the September meeting of the Colorado Springs Astronomical Society. My name is Matt Russell. I am the current president. Welcome everybody. Tonight in September is our, what we call in the bylaws, a business meeting. But we do have a featured presentation tonight. Jill Furman is going to be talking here in just a couple minutes. But before we do that, we're going to go into new visitor introductions. We actually have an election tonight for our officers for 2019. Dave Warner is not here tonight, so we have another member who is going to be doing the What's Up segment, Vince Villa, back there in the back. We're going to be talking about jackets again. One thing that the board, that I will mention, the board did decide that we are going to be using CS Astro versus CSAS because it makes a lot more sense with our marketing plan for the future and what we've been doing for the last 15 years. So we're going to look at the jacket design. If we want to continue with that look, then order the jackets. Alan might be here later on this evening. He did say that there is no cost difference. So for those of you who order jackets, you'll be happy to know that. We'll go into outreach reports, observing reports, or actually no outreach, but observing reports. I know that Devin Delarose, if I don't forget, wants to say something about the U.S. Air Force Academy telescope. And then we'll adjourn. We're probably in the middle. They're going to take, depending on time, but I think we're having kind of a light load this evening. So we might take a 15 to 20 minute break in the middle so that we can kind of socialize a little bit more. What I'd like to do first of all is introduce the current existing officers. Again, my name is Matt Russell, president. We have Jim Marone up here front row, that is our vice president. We have Fred Goodman sitting right in the middle here. That is our secretary. Speaking of secretarial duties, if you didn't hear me mention it, please sign the attendance sheet so that we can make sure that we have quorum numbers, which I think we do. If you're a visitor, please, there should be some cards in the back. Are they back in the back, Fred?
Yes.
Please fill it out. We'd like to touch bases with you after the meeting, or sometime maybe in the next week, so we can figure out, what you thought of things, that sort of thing. I'd also like to introduce our trustees, Floyd Glick in the back there, Scott Donnell right over here.
Treasurer. We
have the treasurer, Joe Furman, and then Stephen Bligo, the webmaster, and then Vicki Kittman, our current librarian. So what I'd like to do first off is, we always kind of do this, is there anybody here today who's a visitor? Maybe it's your first time here. If you want to raise your hand. Would you mind standing up, stating your name, telling us how you heard about us, and why you came today?
Okay. My name is Robert Weeks. This is my son Alex and my other son Aaron. And been a telescope owner and user for a number of years, and just really started getting into astrophotography in the last year or so. And I'm leaving the Army after 20 years as an Army Space and Missile Defense Officer. And I'm going to start working from Boeing next week or next month. So taking this opportunity to explore some clubs and some opportunities that I haven't involved with in the past. And I always have a love for all things space and science.
Right on. Several things. You might want to hook up here with Tom DeClue. He's currently an employee at Boeing, right there. And then also, you mentioned astrophotography. Brian Gibson, which is right over here, will be talking right after the break during our committee segment regarding our astrophotography group that we have. We have a meeting coming up next week. So keep that in mind. Anybody else? All right. I want to pull out the Reflector magazine here, and I was just sifting through this, and I just wanted to specify, we've talked about this in previous meetings, but Bruce Bookout and how BidLAC have been awarded their awards, and they finally got published in a magazine. So I figured I'd say that. Doug Cook, who is not here tonight, who's running for vice president, he also has just had an article published in nature.com. His article is titled "The Evidence for Large Paleozoic Impact Craters Strewn Fields in the Rocky Mountains." He's done a ton. He always is. He's actually up there right now in Wyoming. I think on a personal trip, but he's done tons of impact crater research up in Wyoming, kind of around that Casper area, kind of where we did. I don't know if it's just north of there or wherever it is, but he's done some really, really neat stuff. So if you can look up that article on nature.com, probably be a fascinating read. I have another something that I'd like to say. How many people here have participated in outreach this year? Half the room held up their hand. I don't know if you guys have heard this, but I got a message from Dave yesterday. He states, "We're currently sitting at number 6 in the nation for outreach by the JPL Night and Sky Network." That's pretty darn impressive for the size of our club and for what we've been able to do. LA is right above us at number 5. So think about that, the population center there compared to here. So,
Who's number one?
Huh?
Who's number one, dude?
I did not have a chance to look at the list today, who it was, but I think these guys deserve it. All right. So up next, I would like to introduce our treasurer, Jill Furman. She is going to be talking today about radiation-hardened electronics for space. You have the floor. Do you want me to trump away?
Sure. I left the white background, so it should be good either way.
Okay, well, I'll leave on you.
Thanks for having me speak today on radiation-hardened integrated circuits for space. I'll let you move me forward. Just in case you're wondering, why is she talking about this? My basic background, I have a BS in electrical engineering from the University of Wisconsin at Platteville. I decided not to get my physics degree because that was a whole class extra and I was kind of done. College student. While I was studying there, I went to CERN and worked on the Large Hadron Collider on the muon detectors. I personally got to continuity check most of them. A lot of fun, great summer student job. Went to the University of Wisconsin, got my master's in electrical engineering there. I worked on the negative index of refraction materials. So if you want to know how to make yourself completely invisible to a 10 megahertz signal and you're the size of a grain of sand, I might be able to help. Harry Potter cloaks now. Way far away from that. And completely unapplicable, I got my master's in business from DU, you know, something useless. Next. So next, what do electronics in space look like? This is a generic question from the audience. We have technology number 1 and technology number 2. Any guesses from the audience about what electronics up in space might look like?
Number 1.
Number 1. Now, in what year was number 1 a popular technology for commercial products?
72.
Since the 70s, 80s, you're absolutely right. The current technologies up in space look like the 80s. So let's use a case example about what's up in space right now. I'm going to use the Juno cam on the Juno mission. That's something that I think a lot of us have heard about. It's a pretty popular program out there. The Juno cam launched in 2011. In 2011, it had a 2 megapixel camera up on it. That's a literal camera that's flying out there in space. In comparison, Nikon, 6 years earlier, in 2005, launched a commercial product, low grade, 8 megapixel camera. 4 times better. That was 6 years before Juno launched. You would have thought maybe they could have integrated that. It's not. 6 years is plenty of time. Good things. Let's look at what the pictures would look like if you were out in space. JunoCam results, beautiful. You launched that Nikon, nothing. You would have got nothing at all, because that Nikon is not designed to survive space-based radiation. It would be toast. So let's talk about what's up in space that would make that Nikon toast. Ionizing radiation is not your electronics friend. Ionizing radiation is anything that pops an electron or a hole, creates a charged particle out of a molecule or an atom, causing them to ionize. That's why we call it ionizing radiation. Ionizing radiation is things in the X-ray and gamma ray ranges. It's also, to some extent, the ultraviolet. And it's not a specific wavelength because different molecules or atoms ionize at different energies. So somewhere between 10 and 33 electron volts for those physicists who like electron volts. When we think about ionizing radiation, think about our ionosphere. Our ionosphere is named that because it helps protect us from ionizing radiation. That energy doesn't come from outer space to us because we have protection. Let's move on to the next one. So what is in outer space in terms of ionizing radiation? We're going to use Jupiter as an example. Jupiter's got a magnetic field. Anytime you have a magnetic field, you have a current. And what's moving around in space? Your ionized charged particles that are floating around in space from various collisions, as well as from such fun things as things like the solar wind that are ejecting charged particles. And if we look at Juno's mission, when they were flying around with their electronics, they were trying very hard to avoid these colored areas of the radiation belts around Jupiter to try to protect their electronics a little bit better. So what is radiation hardening? It is a technique that we use in electronics to make the components resistant to damage from ionizing particles. Absolutely critical in space-based applications. So all of your space-based telescopes and all your satellites are ready for radiation. Anything in high altitude orbits, anything that's coming near the ionosphere or outside of it is also something that needs to be protected from charged particles. If you're hanging out a nuclear reactor or by a particle accelerator, they're also generating these very high energy particles that will blow up and otherwise destroy your electronic components. You need to protect those. If you happen to be in a nuclear accident, you've got a problem. If you happen to be in a battlefield or explosive environment, you could also have problems. So some of the circuits that we've designed for radiation hardness are involved in mining explosives. You want to be very certain, did that detonate or not? I need to know from my electronics, I need to read it back out, because in the process of explosion, you can have some very high energy charged particles. And our medical devices, remember those X-rays, those are in the ionizing range. So if you're in an X-ray machine, the electronics in there need to be protected against the X-ray radiation that is in that machine. And as well, I'm throwing this up here, coronal mass ejections. Remember that solar wind, if it's too strong, if it comes through our ionosphere, you're going to get those charged particles coming along. You can fry all your electronics. Consumers, don't worry about this, government's money. Our electronics are just going to be toast. So interrupt me at any time. I'm trying to give kind of a higher medium level. We've got kindergarten students here, we've got PhD students, and we've got everybody in between. So I'm cruising along at 8th grade. If I start getting too deep or you need more explanation, let me know. We have time for questions. Okay, radiation damage. Semiconductors. They're the material that most electronics are made out of these days. Semiconductors are in a crystal form or a lattice structure. When you impact it with a very high energy particle, you can pop a piece of that lattice structure into a different location. So consider this like you are walking in a forest made by humans. Trees planted in nice, lovely rows. And all of a sudden, you're running along, you're having a great day, you're cruising through this forest because it's easy to move through, when the tree just magically lifts up and moves over and gets in the middle of your channel and blocks your path. Now you, as a person running through the forest, are going to be slowed. You're going to be impeded by that tree that's out of place. If that happens enough, you will have a hard time moving through that forest as a person. The same way, your electrons, which are moving through this lattice crystal, are going to start to have a very different behavior. they're not going to be able to go as fast, they're going to get stuck, and more physicsy stuff happens. So in the physics land, we're going to change the band structure of the material. Anyone know what that means? Do we have any chemists or physics in the room? We got like 3. Cool. These are going to be permanent and non-repairable problems. You lift a tree up and you move it around in the forest. Let's consider that a permanent and non-repairable problem. There's no one who's going to lift that tree up and put it back. As well, the charged particles are going to wreak some havoc, but we're going to talk about that a little bit in the next slide. Okay. This is a semiconductor in operation. Anyone ever seen a semiconductor in operation? Ooh, I've got 4. That's okay. Does not matter to the concept here. In order to make an electronic circuit, you want current to flow in known places and to not flow where you don't want it. The way we start out is to create this transistor. This is a complementary metal oxide semiconductor, also known as CMOS. It's a technology name, doesn't matter. What we have around here is positively charged particles. And we've created it as such. We've manufactured it to make that positively charged. Then we take our electron gun, the real thing, and we jam electrons into these 2 wells. So we create a situation of positive and negative charges opposing each other. And then we apply a voltage to the gate, which allows a flow of negatively charged particles to move through it. We've turned the device on. So we've got electrons moving through this. Now imagine what happens when your nicely charged particle from space comes cruising on through the middle of your device. Maybe it's a positively charged particle and it comes on through and it combines with one of these negative ones. 1, no big deal, didn't need that guy. But what if we get an entire rush of them and we get 1,000 of them coming through? Now we've got 1,000 positive particles combining with our negative particles. They, oops, turned our device on. This is where you start having problems with ionizing energy coming through. It can implant itself into the middle of here, implant a bunch of negative charges where they don't belong, implant a bunch of positive charges where they don't belong, create a tunnel right through it. All sorts of different ways and consequences can happen from charged particles getting in the middle of our electric circuit. So what do we do about it? Pizza. The answer to everything is always pizza. If you have a pepperoni pizza that big, size of, I don't know, 12 feet across, if you have 1 more pepperoni, does anyone care? 1 less? I think the guy in the corner over here is sneaking 1. But if your pepperoni pizza is that small, if it's got 4 pepperonis on, 1 more or less really makes a difference. In fact, 4 less and you don't even have a pepperoni pizza. Just have a cheese pizza. So when we think about ionizing radiation, bigger is better. If we have 1 charged particle coming in that's like 1 slice of pepperoni pizza in the middle of a massive pepperoni pizza, who cares? Okay? The problem with bigger is better is getting things into space is hard, especially if they're big or heavy. And therefore, the government doesn't like my plan to make semiconductors huge. So I don't give my way a lot. This is a logarithmic scale, so this is by tens. These are semiconductor processes in sizes from 130 nanometers to 7 nanometers. 90 nanometers, the next process node down, is about the most modern thing we're flying in space right now. This is where your consumer electronics are, down at 7 nanometers. This is cost per transistor. So it is approximately 100 times more expensive for each one, yes or no, transistor in a circuit to put them in our standard space technology. There's an offsetting factor that says, by the way, when I use really, really small technologies, I have to use really, really precise, really, really expensive equipment. So that costs me a little bit more. So when you normalize it, it gets down to only a factor of 10. It's only 10 times more expensive to put thinking large transistors that we're currently using to think in space than it is our commercial stuff. So consider a computer. If you're going to fly that computer in space, it's going to be 10 times dumber than the one you have here. Take all your processing power and say, oh, I only want to use about 1/10 of that. Certainly limits your abilities. So let's look at the next way to deal with radiation exposure. Shield it. Put on your tinfoil hat, or in this case, put on your 2-inch thick lead. It's generally sufficient. The government gets on me again. They don't want to fly 2-inch thick lead around all my electronic components. That's a little heavy. We can still shield it. Hermetic shields are popular and required. We don't want to put moisture in space because we need it up in space. That moisture wants to escape. It wants to evaporate. If it's been sealed in, bad things happen. So we generally put small shields on there, hermetically shield around each integrated circuit. But you can also shield it at the module level. You can shield it at the board level. You can shield it all the way at the larger component level. For example, on Juno, they had a titanium vault that they put most of their electronics in. I don't know the thickness of their titanium vault, but they chose to encapsulate the whole thing. Tell out. So shielding is always good. It's a good first step. It helps out a bit, but it's not the end-all be-all to solve our problem. Okay, in the transistor itself, we can change the way we design it to make it much more robust to continue to function longer in the presence of unwanted charged particles. If this is a cross-section look down from above, this here is projecting back and looking from straight on top. So our gate would be projecting out this way, our source and our drain. That's your standard transistor. The other three methods are called annular transistors. Annular as the annular rings in a tree. They're circular. That helps a lot. Can't tell you why, because we're really not allowed to say. Government doesn't like us to mention these sort of things, but you can use the internet to get a good idea. I'm just not going to say. But it really helps, and that's one of our main techniques to literally change how we make transistors. It makes them much bigger, which makes them take more space, which makes them better at dealing with radiation, but forces us into higher process or larger process nodes with larger costs. Okay. This is our favorite modern technique. When in doubt, replicate it, recover from it. Thinking about digital these days. Let me use an example of a tree. If I have a tree, it's got, I don't know, a million leaves on it, who knows. And if one of those leaves is saying it's night out and everybody else is saying it's day, I just ignore that leaf. It was a bad leaf, it didn't matter, got plenty of other leaves. If a branch falls off, okay, that sucks. Tree's gonna be a little worse at making photosynthesis, but it'll get along, it'll get by. So if I have a digital memory, I'm gonna make it like that tree, so the memory can lose a chunk or a branch. It's not gonna be as fast, it's not gonna have as much memory, but it'll get by. But like any circuit in space, this tree is the same way, it has a trunk. If it takes a lightning strike directly to the trunk, you're dead, okay? So when we are up in space, we still need to account for that possibility. And we do that with even more redundancy. This time, instead of within the device, we make the devices themselves redundant. We have two types, hot spares and cold spares. If you think about the problems we have, most of them are when the device is on. It's those charged particles interacting with my on device, which is using charge to make its electronic brain decisions. So I don't want my spare to be on because it's taking damage. On the other hand, if it's off, it's sitting in the corner with absolutely no power, a charged particle can zing on through it, no damage occurs. So I want to leave most of my spares, cold spares, off, immune to damage from charged particles, or at least to most of the damage. Still, if you get a particle that's high enough energy that hits you in the middle of the lattice that displaces something, the way of picking up a tree and moving it, that's still a problem, can't get around that. But we've reduced a lot of the damage. Okay? Questions about designing for radiation hardness? Yes?
I did a lot of work on electronics way back in my younger days, back in the time frame before you were talking about. As we moved along, there were some things that we talked about, such as doping. So the first question is, can doping be used on an outer layer of these devices to provide a protection layer?
Yes and no. So to Fred's very specific question, doping is when you implant charged particles into a semiconductor. And when you do that, it changes the physical properties of it. Every semiconductor now is doped. Doing it on the outside doesn't really help because we don't know from where the charged particle is coming. So there's no necessary outside. It could be coming from the middle, the left, right, up, down. Space doesn't care. So that doesn't help. But there are some ways that when the geometries become small enough, there are some benefits. That's as much as I can say there.
Okay. And the other thing I was thinking about when you mentioned moisture, one of the things they talked about when I was in the military, and they talked about a different problem, EMP hardening, but similar scenarios, is that they would pre-dry before they would seal it.
Yes.
And so do they do the same thing
Yes.
in this case to pre-dry these devices before they seal them?
Yeah, you bake them in an oven at about 125 degrees for 4 or 5 days and then seal them.
125 degrees Celsius.
Yes. Yes, the season part. Honey, I'm being a teacher right now. Can you sit down, please? Yes. Thank you. I'll be right back. Okay. Yes.
Just a comment. I was reading about SpaceX and how they do this on their rockets. They don't mess with hardening because it's expensive and slow, and you need specialized people to do it. They every system is just 3 commercial grade computers, and they vote on the answer. And they've not had any problems. So
It's a very popular technique.
These spares.
Yep. And the one problem with that will eventually get them, but it's a probability game, is there is always a voting mechanism, right? There's 3 regular computers, they send in their inputs, someone has to make the decision how many yeses and how many nos. It's when that decision circuit gets struck that you have a problem. So oftentimes, what you'll find is they'll do exactly what you said, but the decision circuit itself, one very, very small part of it will be radiation hardened. So they'll have 3 or 5 commercial grade things, and then, like you said, invest your money very wisely into one little tiny bit that makes one decision.
So if we're talking about, I would be curious in what it would take to make sure you have a quorum.
Well, you need an odd number and you vote. That's all. They don't need majority, not in electronics. Or not everyone, majority's fine, yes.
Is there a reason they couldn't make like a tokamak where you have a magnetic bottle that would just surround everything so anything coming through would automatically be deflected?
You could do that. It's absolutely possible. I would question whether you could get that effectively up in space and power it. But from a just general concept,
Yeah.
that would be very helpful.
There's been some concern expressed about the possibility of EMP. Do these same techniques work for that?
Absolutely, yes.
And what's the relative strength of something like that versus random stray radiation?
I wouldn't be a great person to tell off the top of my head, but I'd say when it comes to things like EMPs, when you're on Earth and you can afford 2 inches of lead, just put it in 2 inches of lead. So if I were to say have a critical infrastructure component that I wanted to protect with spares within the US, I would just take a bunch of pieces, make a big box, and put them inside. That would be your least expensive, most practical, very easy thing to do.
But if you're a military aircraft, that's a different kind of a deal.
That's a different kind of a deal, yeah. Yep, absolutely. Okay. So it's one thing to design for. The next thing you have to do is prove that you got what you designed for. So you need to do some level of testing. This is a standard cobalt-60 source, and this would be something in the path of being irradiated. Your standard test is called total ionizing dose, and that is looking at cumulative damage over time. Total ionizing dose is like putting a house in the middle of a hurricane and saying how to do. Did it last 2 minutes or did it last 4? That's what you're doing when you do total ionizing dose. It is this massive flood of charged particles that's much, much, much in excess of anything you'd ever see in space. And you're running this test for a very brief period of time, somewhere in the 2 to 10 minutes to simulate how long something might last 10 to 20 years in space. It's a nice, fun test. It's really, really fast, but it's not necessarily a good physical representation of what would happen in space. So we have the second test called ELDERS, Enhanced Low Dose Rate Effects, which irradiates it only on the order of 10 times more than you would generally find out in space. That way you get your test times down to 3 to 6 months when you're looking at 10-year life expectancies. You're not waiting 10 years for your results, because that'd also be prohibitive. And what you're looking at is the single event effects. You're looking at, is it a change of one memory bit? Well, that's fine. We have lots of memory bits. It's okay if one reads the wrong number every once in a while. Is it an analog effect? That one transistor does the wrong thing and your analog to digital converter has one really weird bit? That's what we have averaging for. We'll throw that out. No big deal. Does your circuit latch up? Does it stop functioning but retain functionality upon power cycling? Well, that's not the end of the world. We can cycle the power and we plan for that. So depending on the use case of that piece of equipment, that might still be approved for space flight. Or does it straight up burn out, cause a flame, go poof? That's considered unacceptable for space flight. Okay. So if you want to fly in space, who tells you what you can do? The US government, the Japanese government, the European Union, all of them have very similar regulations. These are their names. We go by QMLB and QMLQ, and now QMLY, which is a flip chip package. But let's think about the initial qualification. It takes about 200 to 400 parts to do the initial qualification. Your life test is half a year in accelerated life conditions. And you are testing for that total ionizing dose using your gamma ray source, looking for the single event effects, demonstrating to a reasonable population of parts that your part survives. This is just the radiation effects. We're not talking about the acceleration tests you have to do, the hermeticity and sealing tests, the shock divide. There's a very, very long list. Once you've passed this qualification that says that your part, generically speaking, is fit to run in space, then every new manufacturing lot also has to be qualified. So if I used up all my first lots of parts and need to make more, I've got to go and break another 50 parts. If I'm flying the Juno mission, got one camera, I had to break 400 to 600 different parts in order to fly one piece of electronics in space. Now, me as the manufacturer, I'm going to charge you for that, so that one part that you fly up in space is going to be really, really expensive. So let's talk about the consequences of all of this. Qualifying components for space, military grade, takes forever. Normally takes 2 to 3 years, and that's if you're on a good path. And that's the qualification, not the design, not the manufacturer. That's just get the government to give me the sticker that says I can fly it. Our components are heavier, larger, and slower. For example, about a 15-year-old computer processor technology, one of them, is about $50,000 to $100,000 for me to sell it as a space qualified part for the government sticker. You could buy that. Well, you wouldn't buy that. You'd go dumpster diving for it. You'd go, you'd go look in your basement and see what you put on the shelf after the laptop slowed down. So that's why, when you think about the Juno mission, it launched with over 10-year-old technology on it because it was important for a lot of these government flights. They're not running SpaceX style. They're running parts qualified, known to operate in space, can go at least 10 years, maybe 20 years on the mission, and that's how we're designing it. So that's why Juno's camera kind of sucks. On the other hand, the communication circuits they were using at the time, if the camera was better, they couldn't have got the pictures back much faster. So it was commiserate to their mission. Yes.
So there's been a lot of talk in the Air Force lately about how they need to move faster, less time to put a new satellite into space. So how do you have, I don't know if you have any knowledge of this or what they could do, because you're saying it's going to take forever, and they're saying that's unacceptable. How is that? How are they going to bridge that gap?
So the LEO orbit's a really good example of that. there is about 6,000 satellites that are being qualified and ready to launch into the LEO orbit. 6,000. This is a massive orbit. The GEO orbit has large, stationary, long-lasting birds. LEO and kind of the CubeSat revolution that's going with it, I consider these disposables, space disposables. The only requirement you have with them is that your space junk burns up. If it lasts 5 minutes, no big deal. If it lasts 5 years, great. But where they're going with this, the technology, the speeds we want to be communicating at with our satellite communication is so fast, is moving along so fast that we don't want to launch a bus-sized satellite that's obsolete by the time it gets up. We want to launch things that are a meter or less into space as kind of space disposables with the concept that they're only going to last a year or two. In which case, you don't need all that much radiation hardening. In fact, if it just fails on its way up, as long as the one circuit you have in there is burn yourself up in orbit, that one's guaranteed to work. Everything else can fail. So I consider it the disposable forks of space. We're not using cutlery anymore. We're using plastic forks. So they break.
The whole idea behind microsats is really where a lot of this is going. Is like a swarm of them, and it's really 2 or 3 or 4, no big deal, as long as they can still support the critical functions that you.
Yep.
Everybody's happy.
And that, our communication speeds, 5G and on up rolling out, we're going to change our mind about what those protocols are so fast that we want our space-based communication to keep up with us. So, yeah, 2 years are obsolete. Throw a new swarm up. We want to be really cheap.
Trying to figure out where to ask this question or whatever, but it was an interesting situation. I got contacted by a company that thought there was a Pikes Peak observatory on top of, the summit. And I tell them that it didn't exist. And they said, oh, but this is what we're trying to do. And the company was creating microchips or whatever, and they had them all on a big board and all this kind of stuff, tied into a computer, and then they were going to tie it into the internet. They could monitor, but they wanted it at a 14,000 foot altitude. And they only had them on a couple mountains around the world. Well, of course, there's Pikes Peak sitting right there. So I ended up putting the company in touch with the Pikes Peak Highway people. And they said, sure, what do you want to do? And so they used one of their buildings up there to put all this stuff inside. And they weren't worried about the building shielding anything because they were after the effects of neutrons on their chips. And so they set the whole thing up. It was supposed to run for about a year, but there was an Achilles heel to this whole process. The Wi-Fi up on top of it sucked, and they couldn't keep in contact with their chips and the computer they had up there. So they ran it for about 90 days, is my understanding. Paid the Pikes Peak Highway people a lot of money to allow them to use their building. But I just thought that was an interesting concept. You were talking about a radiation source here or whatever, but they were just going to use nature.
Yeah.
Put it at a very high altitude and just see what happens to their electronics.
Yeah, the higher up you go, the less protection the Earth gives you. So, yeah, it's helpful, but you're better off to go spend $10,000 putting it in front of a radiation source and be done. It's not that expensive.
Yeah, and I don't know if their commercial product was going to be for eventually a military MILS standard they were trying to meet or something else that they were trying to meet. Have you ever used RAD over here on Cincinnati?
Yeah.
Okay.
I used to work with Cobham, which is ex-Aeroflex, which owned Brad, which, yeah. Worked with those guys for a while.
Use neutron guns and okay.
Yeah, that's where, if you look at Garden of the Gods, about half a mile up, there's a sign that says Cobham Advanced Electronic Solutions, probably just Cobham. Used to be a company called Aeroflex, and they do radiation-hardened integrated circuits. Again, for your space-based applications, for your medical applications of X-rays, and for your mining explosives.
Any information that you have about the Parker satellite that's being right close to the sun?
I've got no information on that one. Didn't look it up.
I'm just curious as to how old this technology is as far as to be able to handle that environment.
Anything else? Well, thank you.
Great. Thank you very much. Kind of a tradition here at the Power Colorado Springs Astronomical Society, for those who step up to the plate and give a wonderful presentation, they get the coveted and priceless Colorado Springs Astronomical Society mug. Thank you very much. Okay, up next, we're going to handle the officer election. So, Mr. Secretary, what is the number that we need for quorum as defined by our bylaws?
Mr. President, we needed 36. With proxies, we have 43. We're good to go.
Okay, so at this time, I'd like to hand over the floor to our trustees, Floyd and Scott.
Wait till we're done and see if you like the results. So, all right, so we'll, we have one contested position. Let me kind of go through the positions that in total. And so starting with the member at large position, that's uncontested, and Mr. Tom Mulliken. There you are, Tom, right there. So for the uncontested positions, it'll be just an automatic, there's no vote. So then we go on to the treasurer, and Jill Furman, who's our current treasurer, is running uncontested for a second term. And let's see, then we go to the secretary, and Vicki Kitzman, right there, and it was nominated and is uncontested for the position of secretary. All right. And I'm going to skip to the last uncontested position, which is Mr. Matt Russell, is our current president, nominated and uncontested, and so he will continue on as our president for the next year. So that leaves us with the one position that is contested, and that is the vice president position. And the two candidates for that are Doug Cook and Gene Schimmerhorn. Doug is not able to attend tonight. Matt, you mentioned that he's up in Wyoming, meteor stuff. And Gene Schimmerhorn, I don't see you here. Are you here? Okay. So one of the things that we wanted to do before we pass out ballots is give each candidate an opportunity to get up and give their campaign speech as to why they should vote, why you should vote for them. Since neither one of them are here, we'd be unable to do that in person. Doug Cook did provide in advance a three-slide PowerPoint kind of doing that. So we'll just kind of step through that. So here's Doug Cook, and he's the candidate for the CSAS Astro vice president.
We're working on it.
Right. So I'm just going to go ahead and kind of walk through the slides for Mr. Cook. Lifelong love of astronomy, as pretty much all of us here have. He's been a member of CS Astro since 2016 and is currently a lifetime member. He's also an active outreach volunteer, and in 2017 served as an officer in the member at large position. He's also a member of the Long Range Planning Committee, working with Bruce Bookout with the Air Force Telescope Project among those projects. He's also a Rocky Mountain Star Stare merchandise chair and presenter, okay, and an avid astrophotographer, and adjunct astronomy professor at Pikes Peak Community College in 2017. Author of the book, The Aquila Mission, 34 years as petroleum geophysicist, head of a $2 billion exploration project in Saudi Arabia. That's why he wears that white hat. Keeps the sand out of his head. Led the Saudi astronomy outreach program over there for 10 years. He's currently the chair of the AAPG Astrogeology, led 4 national astrogeology seminars. Leader 2017 Total Eclipse Astrogeology in Casper, Wyoming. So he's one of our individuals that provided another program in addition to the others that we have there. Co-author on 10 terrestrial impact papers for the AAPG, the I don't even know what LPSC is, Maps, Nature. Anybody know what those are? Looks good to me. All right. Delegate Space Settlement Symposium, Lunar Planetary Society, what's the C?
Council, I don't know.
Council? I bet you the LPS is Lunar Planetary Society. Humans, because that would make sense, because they're the ones involved in this, Space Settlement, Humans to Mars Summit. Okay, and 2018 Legislative Blitz participant, advocate to Congress for NASA. I didn't know that. All right. And that is it. Right? Okay. Last slide. So, Mr. Gene Schemmerhorn did not provide any slides or anything that he asked us to read or present in his absence. So with that, are we ready to go ahead and, Mr. Secretary, I understood we have the quorum, so we were able to proceed with the votes. All right. So with that, let's start passing out. Okay, so I'll just start in the back, I'll start in the front. If we run out, I'll have to have our president man the scissors and cut up some more of these.
Since neither our president here, do we need to do it this way? Couldn't we just do a vote?
Want to?
As long as it's legal to do.
Good.
Against their bylaws.
Okay, I went to all the trouble to make up.
That's what
They look
Fantastic.
CSAS. Floyd. We're gonna do a hand vote since these are candidates here. Just do a show of hands. I would also say that we have four. So I'll lead off with we have 4 proxy votes. I'll tell you what they are to not influence the voting outcome after we have the hand count. So let's start with in the order in which they appear in the ballot, which you don't get to see. It's really a nice ballot, though.
Could you put it up on
Okay.
the screen for us?
Yeah. So let us have a show of hands. All in favor of Doug Cook as vice president, please raise your hand. And keep them up until Floyd has had a chance to count them.
If we proxy, we don't hold our hand up.
No, you do, because if you're here, I took you off the proxy list. Okay. You can't vote, are you? You want to see my All right.
I think it's
Okay, so let's have all those in favor of Gene Schemmerhorn, please raise your hand. Okay. In addition, we have four proxy votes for members in good standing who are not present tonight, and all 4 of those proxy votes are for Doug Cook. I think we have a unanimous decision. Sure, nobody wants to vote for Doug Cook, right? We're good. Oh, you want to give? So we have 1 vote for Gene. All right.
So he's just waiting.
I believe that concludes the election. So we have the uncontested officers. So congratulations, Vicki, coming on board. Congratulations, Tom Mulligan. Congratulations to Jill and this guy here, Matt. And to Doug Cook. So congratulations.
Okay. What we're going to do now is we're going to take a break, and we will come back here at 7:45, which is in 22 minutes.
We made all of this.
Yeah. We upgraded. Yeah. I kind of like these longer breaks. What do you guys think? Yeah. So who's bringing cookies next month?
You.
That was the
new president.
The new president. Yeah.
You
All right.
brought it up.
Okay, so what we're going to do next is getting back to business here. Actually, this is a business, but Dave Warner is back here that does our normal What's Up report. So Vince Villa has decided to take that on. So thank you, Vince. So come on up.
Thanks, man. So anyway, hopefully I can follow up that fantastic presentation with a good What's Up here. Yeah, Dave mentioned that he would be happy to have a little bit of help on these when he needs them. So give it a shot here. September, October. So next slide. We're going to go ahead and knock out the lunar information because most of the time I just see that as a nuisance. September's full moon, more or less today. The harvest moon, which is whichever full moon is closest to the autumnal equinox, which happens to be September, sometimes October, or sometimes known as the full corn moon. Okay. I started to think, why don't we name new moons? Because that's what really matters. So that'll be October 9th, and maybe we can call that the Andromeda new moon. And then the October full moon before we meet, will be the hunter's moon or the traveling moon. So next slide. We're going to look at the next couple of slides. We'll look at tonight looking east, then October 9th on that new moon, and then the next full moon or our next meeting looking east to look at the constellations that will be well positioned for early evening viewing. So next slide. And we can see Pegasus, Aquarius, Copernicus, Andromeda, Cassiopeia, Cepheus, Cygnus. Next slide. Not much change. Next slide. Not too much change. Probably the middle of those is going to be the best viewing without the light getting in the way. So next slide.
The light was getting in the way.
That's right. Went from full moon to new moon. All right, so now we'll look at zenith on the 9th of October, and then we'll look north and south as well. And these are kind of the areas that will be best for looking. We can see Cygnus is still well positioned. Of course, Cassiopeia and Andromeda, Pegasus. Riga. Next slide. Actually, I wanted to come back and point out these Draconids, the dragon. If you're thinking, what meteor shower is that? That's because usually it's not a good one, but there's a neat backstory. Next slide. And then looking south, we can see Cetus, and actually all the planets are up as well. So if you want to chase after Uranus, it's up there. If you want to go look for Mars, it's still going to be well positioned, and I'll get to that as well. Next slide. So this Comet 21P Giacobini-Zinner that Dave actually pointed out this last time, and it was well positioned for viewing last month. It was probably better for viewing. Actually, it seems to be getting dimmer. It's past perihelions, and it is coming up later and later, earlier and earlier in the wee hours of dawn. Neat backstory, though. First of all, it was discovered by Giacobini, and then it was lost because they calculated the wrong period. Rediscovered by Zinner, so that's why it has the name. It's actually the parent object of that Draconid's meteor shower, which happens to have its main radiant night coming up. In fact, you could probably watch the Draconids and stay up and see the parent object that evening. So next slide. And you can see that we're pretty close to new moon here. That was the 9th. On the 8th here, you could be watching the Draconids, which actually peak on that evening. And they're going to be just towards the north, maybe setting. Next slide. Stay up until 2 o'clock in the morning on that new moon night, and you could then actually see the comet starting to rise over here in Orion, which I thought was kind of cool. The next slide. Then we've got these wonderful Messier objects. If you like open clusters, this is a great time to be viewing in Auriga. We've got M36, 37, and 38 almost in close succession. You'll see the medium clusters, and then a nice rich cluster, and another medium cluster that has the name Starfish cluster. So next slide, I've got a screenshot of that. So Capella in this slide would be just off to the upper left here, And you've got M37, which from a dark sky like Starry Meadows, you can generally see naked eye, as well as 36, 38 is a little bit harder when you view it with the telescope. It's fantastic. Next slide. So looking and switching gears at the planets, we're slowly saying goodbye to Venus. You can kind of catch it just down low to the horizon, depending on how close you are to the mountain there. It's going to return as a morning star in November. Saturn is south to southwest at sunset, still in pretty good position for viewing. And Jupiter is getting lower and lower to the west, and will actually be returning as a morning star in late December. Mars, interestingly enough, is catching up on its previous ground that it had covered when it was in retrograde. It's now back in prograde motion. So it's actually also running against the way that we are moving the sidereal motion, and so it is actually going to stick around for a little bit longer. Next slide. As a matter of fact, if you go out there on this new moon night and you look at Mars, say around 9 o'clock at night, and you'll notice this little pattern of these stars over here. It kind of looks like that. What is it? The Crown constellation. Yeah, thank you. I'm not sure if that is. But it's a nice pattern to anchor on, and the reason I bring it up, next slide, had you stay up until 4 in the morning to see Mars when it was first coming around in June, it was almost exactly in the same place, and I thought that was kind of cool. Yeah, so that's Mars, and we'll go to the next slide. So one other kind of neat tidbit, if you like interesting things, you can actually see the position from where everything we refer to is measured against the first point of Aries, which is actually in Pisces. 0 hours and 0 declination right ascension. So next slide, if you go back here to see this and you look at this kind of distinctive pattern that is actually the main part of the constellation of the Whale there, you're not too far off from it. Next slide. Sorry, yeah, see this Pisces. So I pointed out the wrong one. They're similar. So then you're about 5 degrees from that. And if you look right over here, you're at dead 0 by 0, which I kind of thought was cool. And it also gives you a reminder that there might be warmth coming after the cold winter, right? So I always look for these little clues like that, right? And so this is exactly where the sun would have been in the springtime, January 1st, 2000. Next slide. So switching gears, if you're just getting back into the hobby, you're looking for some easy things to look at with your telescopes. I'm going to go from kind of easy to more challenging here. This is just Vince's selection of what I'd be looking at in October. So first is the Hades cluster, which is actually part of Taurus the Bull. You get that nice orange Aldebaran and this little V shape that generally precedes the Seven Sisters. Which is right after that Pleiades cluster. Right? Seven Sisters are going to be well positioned for viewing. That one's actually a Messier object, and there are well more than 7, depending if you're looking visually. Most people don't see 7, they see 6, and there's this mystery of where's the 7th sister. And if you look through telescope, there's many more than 7. And even actually the Hades cluster has over 100 stars, even though it looks like the main 7 in that V pattern. Up to the north that we saw on those slides, you've got Cepheus, and Cepheus to me always looks like a little house. Depending on which way it's positioned, it looks like an upside down house. You look at the foot of the house, the foundation, and make a little triangle that's not really an equilateral, but just up from the center of that foundation, there's a little orange star. You can actually see it visually pretty well. Through a telescope, that looks fantastic. It's called Herschel's Garnet Star. It's a beautiful carbon star, one of the most colorful stars that you can look at through telescope. We already mentioned the clusters, but we didn't mention the double cluster. So if you look at Cassiopeia, you've got the big triangle and the smaller triangle that make the little M. If you come down from the smaller triangle to the lower right, you can see a little faint fuzzy from a dark sky like Starry Meadows. You look at that through the telescope and your eyes pop. It's gorgeous. Those are all within reach, I would say, from moderately light polluted skies like a suburban backyard. And then, of course, we've got the star of the show, in my opinion, Andromeda. So M31 and its companion galaxies, Messier 32 and 110. This group is well positioned and nice and high in October, and through a, let's say, 8-inch or better scope, you can actually see dust lanes in the spiral structure of this galaxy. It's quite wide. We're talking, many times maybe 6 or 7 moon widths wide. So you're going to want a nice low field of view, or if you eagle eye in on it, you'll be looking at exactly what Hubble of Hubble Space Telescope fame was looking at when he was measuring those special types of stars called Cepheid variables. Those have this unique property that you can study their light curve and how long they take to go through one of their cycles and figure out just exactly how far away they are. And Hubble actually determined that Andromeda was not a part of our own galaxy, hence the fame that he was able to go. It laid to rest a big controversy that wasn't all that long ago. You think that Hubble was doing his work in about the 1930s. And so prior to that, they weren't even sure if there were external galaxies outside of the Milky Way. So some of that history might give you appreciation for this. In a larger telescope, something like a 12, 15-inch in dark skies, you're going to actually be able to see globular clusters and dust lanes in that area where new stars are being formed. Well positioned also is Myra, the miracle star. If you like variable stars, kind of like these Cepheid variables we're talking about, this was one of the first ones discovered. It's a long period variable that ranges from anything to can't miss it second magnitude, very rarely. Usually it peaks around third magnitude, to can't see it at all, ninth magnitude visible. So it's actually a pretty neat object. Going with a little bit more challenging, I threw an NGC 7331. NGC 7331 is an edge-on spiral that through a moderate-sized telescope, talking around 8 inches or bigger, you're going to see a nice enough amount of structure to go, yep, that's definitely a spiral galaxy. It's a pretty target, and it's going to be pretty close to zenith, more or less. And it's fairly easy to find because it's right off of the main square of Pegasus. If you play these little star hopping games, there's an easy way to get to it. So Triangulum Galaxy M33, you can Google all these as well. Sorry I didn't have star charts for every single one of these. I wasn't sure how quickly we would get through these, but of course that is one of the famously difficult objects to see because of its low surface area brightness. It is actually a fairly bright object, but it's so big when you look at it through a telescope that the light is spread across much of area. I gauge a position's dark quality if I can see M33 or not. And it may or may not have anything to do with the site conditions, but could have to do with moisture or local environments. So it's not a foolproof method. However, I will say this, it's one of these, if you see it, you're definitely there kind of thing. So if you can look directly at M33 and see that faint fuzzy without any amplification in a telescope, you are in pristine sights. And Starry Meadows has passed that test many times. So the Veil Nebula is up in Cygnus. It's actually off of one of the wings of the Swan. It's fairly simple to see because there's another star that goes right off the wing and you go right into the middle of it. Beautiful target. You're going to want a bigger telescope for this. These are the more challenging objects. And then Stephan's Quintet is actually close to NGC 7331. You can almost fit it into a wide field of view with that NGC 7331. You're going to need a big light bucket for that, but it's beautiful. You can see 5 galaxies in one eyepiece, almost like waiting until spring, but not having to. And that kind of rounds out my list for what's up in October. Any questions?
All right. Awesome. Okay, we're going to move on to observing reports. Does anybody have an observing report? Brett?
Well, it actually stretches out a little bit, but as some of my buddies know, I've been observing and imaging planets while we're in the season, and I've had some great views as well as images of Mars, Saturn, and Jupiter, all stretched out over about a 2-month period.
Yeah, very cool. Wow.
I gave a couple of images lineup. At September skies, we've tracked down 21P, the comet that it's just talking about. And so I shot this through my 20-inch StarMaster. The DSLR. This is a 30-second exposure. So it's kind of fun. It was up in Riga at the time. And then the next image is just the moon at the public star party last Friday. But this is actually taken with my iPhone. If you turn the lights back on. What I did is a while back, I bought one of the adapters to adapt your phone to an eyepiece. And I realized that what I could do is take off the adapter part of that and make a plate. So this is just a little 15mm eyepiece in that clamp. And then I clamped a plate to it. And so the eyepiece is up here. And then I put some shelving material on, or just some sticky. And then and then I set this in my telescope and pointed up at the moon, so it's about an angle like that. And then people could come by and actually lay their phones on there, position it, and actually take their own picture of the moon.
A bunch of us here have those pictures in our cell phones.
Yeah, so a whole bunch of people have pictures. That was kind of fun.
Very cool.
Awesome. That's nice. Very nice.
Yes.
Might have been.
My name's Bill Keybon. Been doing a whole bunch of outreach. Dave. And this past week, actually got a couple of firsts for myself. Chased the ISS, zenith to set through my little 70mm scope. Managed to see panel detail. And saw bands of Saturn.
Very cool. Now, when you were tracking the space station, did you have to manually do that, or did it?
It's a manual scope, so I had to.
Oh, you did.
Yeah.
Wow.
You did that.
That's
you
pretty
did
tough,
that-
man.
You did that at Horizon, didn't you?
No, I did that at Bear Creek.
At Bear Creek? Okay.
Yeah.
Very cool.
When it was a nice south to northeast overhead pass, so.
That's awesome. Floyd, did you have something?
Well, I saw some of those things. Planets, we waited in and we caught Neptune and Uranus also. And we looked for the NGC 7331, found that. It's a nice galaxy. It's pretty bright. And we also looked for NGC 6543, which is planetary nebula up in Draco, the cat's eye. And not too far away from that is the NGC 40, which is a Herschel planetary nebula. But it's very dim. It's really hard to see with a big moon. So we'll try again when it's darker. So,
What size scope do you see?
16-inch.
Okay. I tried some of those, that you just mentioned with an 8, and I struck out.
Anybody else?
So also September Sky Stairs, one of the coolest things that I've ever seen, like I hadn't seen it before. Tumbling satellite, which is common enough, but moving so slowly that it probably took, I don't know, 10 minutes to go a couple of degrees or whatever. I ran over and told Tom.
I was going to mention September Skies too. Thanks to everybody for showing up. That was a great time. The burgers were good, the brats were good, the company was good, and the skies were even better. So one thing that I remember was that my little 71-inch or 73-inch or 73 inch.
Wow, that'd be really good.
My little size matters. 73mm APO, looking at the entire Veil Nebula complex with a 35mm eyepiece. You can see the entire circle, west, east, the middle, filaments that kind of go up. It was just, as my son would say, it was sick. So it was pretty sweet. Lastly, I think Dr. Delarose would like to say a couple words.
Well, maybe a good prelude to that is you could give the report from last Friday night star party at the observatory.
Okay. Scott, you can also chime in here too.
we were invited, the executive committee was invited to the United States Air Force Academy Observatory to actually look through the 24-inch Baller and Chivas telescope. Bruce went, George White went, Scott went, I went, and Tom went. No, Tom didn't go. You did go.
Tom was there.
You did go. That's right. I remember drunk again.
He was in the back seat.
He was in the back seat. That's right. We had a great evening. I mean, it was the skies were far less than optimal, but it was a very neat experience seeing how the telescope operated. Scott broke things and Devin had to fix it, so he was playing around, slewing
Testing
things.
resiliency of the
That's it.
system.
Right. So we were actually controlling the telescope. Basically, our club was controlling it. Well, Devin was
And switching out eyepieces.
doing his deal, and it was really neat. So
It was great.
yeah. So go ahead.
All right. So the reason for that visit was that the Astro Society, CS Astro, is inheriting that 61 centimeter telescope. It will be disassembled and removed starting 2 weeks from today to make room for a 1 meter telescope, fast tracking telescope that we will be getting in a year. And the contract for that, the government contract, was just awarded this last Wednesday. And so now the real fun starts with the design phase. And so really looking forward to having all of you out there to see that telescope when we get it in the fall of 2019. So everything's kind of moving ahead, and we're excited. I'm like a kid at Christmas, and I promised less than 60 seconds, so there we are.
Very close. Yeah. So you throw us the jacket. Okay, real quickly here. Alan Gorski sent me this photograph of what our jacket is going to look like, just so everybody can see it. Same font, the pricing is the same. I think it was around $73, $75-ish somewhere. Floyd, I know that your jacket is the letters are wearing off. They can actually re-imprint that. They can re-print that as well. This is the one that says CSAS on it, but we are going with this. So one thing that was asked about at the last meeting is that if we want to change the font or do something different. So here's the deal, we can do that, but if we do that, this is the deadline, you have 30 days to do it, bring your designs to the next meeting, we'll discuss it. But the first question I have is a show of hands. Do we want to change this font, go with something else, or leave it as is? So those that want to leave it as is, raise your hand. Okay, those who don't, okay, it's a non-issue.
I had ballots for that.
Good. So the jacket issue and the font that we're using from here on out is this. So go ahead, yes.
So I brought this up at the last meeting, but I don't know if it got much traction. Is there any possibility of putting a space between the CS and the
I like that idea a
so
lot.
it's not Castro?
Yeah.
I know, I was thinking,
Yeah.
when you put the
CS
image
space
up there
Astro.
for the first time, the first thing I thought of was it says Astro.
Yeah.
Yep.
And unless you had CS above Astro,
So we're not a Cuban-based club?
dude, that's what I was thinking, you know.
I'm from Miami, I don't have a problem with it.
Well, we're gonna sell cigars.
Little Cuba.
Okay.
I mean, first look, is, you know, you're all used to seeing CSAS, but for the general public, if you're walking around and somebody glances at a number, sorry, the first thing I thought of was Astro.
Well, what we'll have to do is we'll have to look at that, because if we do create some spacing there, font size gets smaller, because we're already pushing the edge of the jacket.
Can you put the CS above the Astro?
No, the way that we're branded with CS Astro, with our Facebook, with our website, with everything, it all kind of needs to be right there.
It would have to shrink a whole lot.
Well,
Did you do it like the Broadmoor, where they have their tiny little A?
I'll tell you what we'll do. I will have Alan do a couple different with spacing, so we can actually see side by side the difference. How about that?
It's really a whole stroke. Smaller, you can see us.
Yes.
wouldn't need a whole space if you just put a tiny dock.
Yeah. Or slide.
But then you're changing.
Then you're changing the name.
Yeah.
So what we'll do is I'll have him, we'll create a couple more designs and we'll finalize this next month. That's what we do. Okay? And so that's what we'll do. Anyways, we got to move on. We're going to do committee reports. George is not here. Bruce, do you have a quick update for long-term planning committee?
Oh, all right. Last long-term planning committee was 3 people. If you are interested in being part of this telescope, the Air Force telescope, we need your attendance on it. I am posting to the forums when the meetings are. I am attempting to get the emails out. The last one, I was so overwhelmed at work, I apologize. But fundamentally, what is going on is we are getting things narrowed down to 2 things. Primarily the community and what advisors we're going to have from the committee to the club about this committee and so forth like that. So we need to look at leadership within the entire Colorado Springs, Pikes Peak region community. And so we're trying to build that list up. If you know of and have connections to a city council member, to the president of the Space Foundation, to things along those lines that are community leaders that we can start bringing in as our community volunteers to help us with leadership issues and further, please do. Second item on the list was location, location, location. We are trying to beat out every possible idea to research it. And as I stated, just saying, oh, well, we can put it in my park next to my house. No. For one, which park, who's the contact, and we need detailed work on, how we get the contact, how are they already open to it, things along those lines. We have a list, I believe, of 9. About 9 different locations that we're working. And give you an idea, Florissant Fossil Beds, not only do we have their leader of the Rangers, we have their superintendent, and then the superintendent's superintendent within the National Park Service up in Fort Collins. That's how our leadership line on them wanting to get it done there. So that's we need a chain of leadership that we can talk to about funding lines, about all this other kind of stuff. This is not an easy project. The nice thing is, I know exactly where the telescope is sitting right now. That's going to change in 2 weeks, not 2 weeks, but we know where it is. We're not in a massive, we have to rush at this. Taking our time, we're doing it right. Other parts of the long-range planning are looking at management, operations, maintenance of this telescope. Big picture right now. We're not going narrow because we don't have a building, because we don't have power. We don't have, all these other aspects that'll come in. But we want to look at usage by public, but also you, our club. I want to be able to turn around and train you on how to use that. We're going to have people who will train on to use it. We'll have some key holders. We're going to have 2 levels. One, people who go in and operate the telescope, never operate it by yourself. There's simple rules, there's nice safety. We're big on safety here. That telescope, you don't want rotating and smack you in the head. I know.
We do the same thing with the cadets.
I already got smacked on Friday on it. And I loved every moment of it because it is a beautiful scope when it moves. So we're seriously looking at this in many aspects. If you don't want to be able to work the location aspects, we wouldn't mind some preliminary ideas about looking over the manuals and coming up with training things, any aspect to do it. We'll get more. We're going to have monthly meetings as we go along. So just keep an eye out for it all. Yes.
Monthly meetings on a specific day.
Try to have them on Saturdays, 9 a.m. at the Panera Bread off of Powers. In front of, basically at the main street, whatever it's called. First and Main thing that they're doing. That seemed to be very convenient for lots of people. It turns out all the people who live on the west side of town have to deal with all the people who live on the east side of town. 1, 2, there's multiples here. So that's kind of a balance point between either side to get to. So, okay.
Great, thank you. Starry Meadows property.
No updates on power. We've done everything. We're just waiting for San Isabel to do the job and let us know, basically. We are moving forward, the Star Meadows Committee is moving forward on installing stairs and railings of the observatory that we do currently have at, down at Starry Meadows right now. And the last thing is we made an update on the use policy for Starry Meadows, something that we hadn't thought of before, we should have, regarding camping in the town hall building. So we made an amendment, we put an entry in there that says that there is no camping permitted in Starry Meadows in the town hall building. There are a variety of reasons for that, which we went into in the committee itself, and then the board approved it. But if it's hailing or something, I'm sure you can go down there, no one's gonna care, but no official camping in there, so.
So is your expectation that they'll be able to set the poles this fall, or will it wait till spring?
I really don't know. My hunch says if I was them, I would want to do it before winter, but I don't know. I think you'll have an update by next meeting, something.
Rocky Mountain Star Stair.
A couple things. I hinted Rocky Mountain Star Stair, for any newbies, that's our big star party down at Starry Meadows in June. New Moon weekend in June. For 2019, we have a theme, and I hinted at it last month, more than hinted at it. It is Sagittarius in the Milky Way. That was Doug Cook's suggestion, and everyone that I've run that by thought that was an excellent idea. So that's what we're going with. So now we need a design. So if you're on Facebook, you may have seen a post I put up there yesterday. And I also need to get out, and I will be getting out pretty soon, an email blast to the membership, looking for ideas, looking for input on a design. If we pick your design, by the way, we will be evaluating the designs at next month's meeting and picking one through the process of voting, like we did last time. If we pick a design, the person whose design we pick will get a free shirt with the design on it, obviously, and also an adult RMSS a pass, yeah.
Registration.
So, registration, and so that the combined value is about $65. So that's the compensation you get if we pick your design. So be thinking about that. I'm still putting together my team. We did have a meeting about 2 weeks ago at the Panera Bread on Powers that also Bruce is meeting at. We had a meeting. We're putting together a team. At this time, I've got about half the team put together. I'll be sending out an email blast on that too, because I still need more supporters to head up the different teams that we need to have staff so that we can pull this off every year. I don't think Caitlin is here today, is she? I got her shirt. No, I didn't see her. Okay. One other thing. This is off topic. I'll just bring it up. A friend of mine has an 8-inch f5 mirror that's unfinished, and he doesn't want to finish it because it has to go. It looks like it's finished, but if you look at it close, it's got a lot of pits in it. But it needs to be brought back to a 320 grit and brought back to polishing and repolishing figured. But he's willing to give it. It's an 8-inch f5, which means it has a 41 f5.2. It's got a 41.5-inch focal length. So it'd make a nice wide field scope, fairly compact one. Anybody wants it, let me know. It's for sale for $75, and I've got the equipment in my basement to finish it. If you want to take advantage of the system, the machinery and the equipment I've got, or if you're an ATM or an amateur telescope maker, you can finish it yourself. If anyone's interested, let me know. And the next meeting, by the way, for RMSS is October 20th, Saturday at 9 o'clock at the Panera Bread again on Powers. Any questions?
What are the dates in June?
Right there.
Right there.
Yeah, it's near the end of the month.
Okay, because it looked like there was a choice of end or beginning. of the
Right,
month.
no, that was done on, I think a year or two ago. But we've got, yeah, so actually, I don't know if it's on the website yet, but all the dates for the next 5 years have all been chosen and they've been decided on.
Okay.
Any other questions?
Thank you. All right, last but not least, our astrophotography group update.
Hi, I'm Brian Gibson. For those of you who don't know me, I host at my home, the Astro Imaging Group, and there's been a lot of exciting things that have been happening and some things that are coming up. Last month we had we meet, just for those of you who don't know, we meet Tuesday following this meeting, or 1 week following tonight, for example. We meet at my home. If you're interested in coming, please give me your email and with your name, and I'll make sure that you're on the contact list and get that information. Last month we had Dr. Robert Iron give a beautiful presentation on imaging nightscapes. Some beautiful work that he did, and a lot of people really enjoyed that. And there is, if you're interested in that, he did put together a little sheet of some of the information that he uses. If you contact me, I can see that you get a piece of that. Next month, which is next week, this coming month, we're really honored to have another guest speaker, and that is our president, Matt Russell. As you know, if you've seen any of Matt's work, it's really amazing. He's a well-seasoned, world-class astro imager, and if you've seen his work, you would be very, very impressed. Well, here is a chance for you to find out how he does that processing of his images and how he captures them. It turns out instead of one presentation, it's kind of divided up into two, but here's the information on it. The first of a two-part presentation titled Overwhelming Yourself with Signal. Yes, starlight signal. In the first part, or installment A, Matt will be sharing his imaging routine from start to finish. He goes back to the basics and discusses items that consistently impact the image quality, things that are important. Topics include minimizing risk, so you don't have to redo it and waste your time. Key factors to consider to an imaging session, targeting, selection, and framing, imaging constraints, things that you want to take into consideration, and of course, spending a good portion of time processing the black and white images. Because of the content is, although he says it's very easy because you've done it many times. So probably we're going to divide this up into two parts. The first part will be the basic techniques that are used for capturing images. And the second part, which will be a couple months probably in the future, that time to be announced, will bring in more of the color aspects of it. So for this first time, techniques will include these things, some of the things we're going to discuss and show and demonstrate deconvolution. If these are big words for you, just realize we're out of high school. Nonlinear stretching, level and curve adjustments, high pass filtering, and layer masking. Those will also be demonstrated, not just talked about. The techniques can be used to significantly enhance the CCD, CMOS, and of course DSLR types of data that you would capture. There will be an open question and answer, sharing time after the presentation. So if you want to know how to better your images or to start taking some of your own, all the way around, this is a meeting that you will not want to miss. So this is coming Tuesday at my home. Give me your contact information. I'll make sure you have that location. The second part of the presentation will consist of adding and manipulating color data, balancing color, using the narrow band filters and blending those, filter weighting, and C25 or solar calibration, along with additional assortment of tricks that he has learned over the years to make the images pop. So it should be a great time. And I appreciate Matt for being willing to do this. One other thing is that's next Tuesday. We've decided to try another event down on our property, down at Starry Meadows, the weekend following, because that's the new moon. So if you're interested, the emphasis will be on astroimaging. At first I was thinking, hey, we could call that RMAISS, which is the Rocky Mountain Astroimaging Star Stare. I said, no. Maybe Amazing October Imaging Star Stare. I don't know. Whoever shows up can kind of decide what they want to call it. But it's October 5th and 6th, which is a Friday and Saturday night. For those who can come in, if you don't have any equipment, you don't even know how to do it, actually that's a great time to come because there'll be people sitting up. You can kind of sit and see how people do it or watch. And that's one thing about a group like ours. Unless they have very, 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 very expensive equipment, and some people do, they love for you to touch and look through their stuff and work to it. So it's a great time to do that. So that is Friday and Saturday. If you want information on that, again, make sure I had your contact information, and I'll get that information to you as well. Any questions? Thank you.
Right. Thank you. Okay, that's all that I had. Just a reminder, there is typically a pre-meeting social at Trinity Brewing down the street, and after the meeting social, which is at the Village Inn. You guys doing that tonight? Over at the Village Inn, just right down by I-25. Nobody else has anything else?
David asked just to remind everybody, please keep an eye on the forums and the calendar for any outreach events and come out and support those as best as you can.
Great. You turn.